Welcome to the tutorial over 8-1 multiplying and dividing rational expressions. Your new vocabulary is rational expression and complex fractions. Example 1. We're going to simplify 3y times the quantity y plus 7 divided by y plus 7 times y squared minus 9. So your first step is to look for common factors. So it looks like in our problem, on top we have a y plus 7, and also in the denominator we have a y plus 7 as well. We can actually rewrite this to be 3y times y plus 7. Oh, hold on just a second. There we go. You want to separate these factors. So we have 3y times y plus 7 over y squared minus 9 times y plus 7. So all we did was rewrite this to where we have our two factors that are common in a fraction. And anything divided by itself is 1, so these actually cancel out. So you can say step 2 is eliminate common factors. And then your last step is to simplify. So really all that's left is 3y divided by y squared minus 9. And that's our answer. Alright, so we're moving on to a new piece of this. It says, under what conditions is the expression 3y times y plus 7 divided by y plus 7 times y squared minus 9 undefined? Okay, so in order to determine that, you have to think, okay, we can't divide by 0. So that means if you set the denominator equal to 0, whatever you get when you solve for y will make this expression undefined. So for your notes, you can write, just as with a fraction, a rational expression is undefined if the denominator equals 0. Alright, so the next step, we need to actually take our denominator and fully factor it. So the y squared minus 9 is the difference of squares. We have y plus 7. And the difference of squares, we're going to write our variable, our plus, our minus, and then the square root of 9 is 3, so we have 3 and 3. If we set each of those factors equal to 0, so y plus 7 equals 0, y plus 3 equals 0, and y minus 3 equals 0, and we solve for y in each case, so subtract 7, we get y equals negative 7, we're going to subtract 3, get y is equal to negative 3, and then we're going to add 3 to both sides. Y is equal to 3. So what that means is that this expression is undefined at negative 7, negative 3, and 3. Example 2. For what values of p is p squared plus 2p minus 3 divided by p squared minus 2p minus 15 undefined? Alright, so anytime you see that you want to determine whether or not it's undefined, you have to take the bottom, set it equal to 0, and you have to fully factor. So we have p squared minus 2p minus 15, and we have to factor this. Okay, so our magic number is 15, so we have 1 and 15. We have 3 and 5. And we need to be able to add or subtract to get a 2. Okay, so the factors that are going to give me a 2 by manipulating them are the 3 and the 5. Okay, so we're going to have our p and our p. Now, the bigger factor gets this middle sign. So the bigger factor is 5, so it gets the minus sign. And then in order to figure out what the next sign needs to be, we have to multiply to get a negative number. So that means we need to take negative 5 times a positive number to still make it negative. So we have a positive 3 here. Alright, next step says we need to set it equal to 0. Okay, so set it equal to 0. Well, each factor. So p minus 5 is equal to 0, and p plus 3 is equal to 0. If we add 5 on both sides, we get p is equal to 5, And if we subtract 3 on both sides, we get p is equal to -3. So that means that this is undefined when p is equal to -3 and 5, and it looks like B is our answer. Alright, so the next trick we're going to learn for example 3 is we're going to simplify by using -1. So the first thing we need to do is we need to factor the numerator and the denominator. Anytime you see rational functions like this, you always want to factor. That should be your first thought, is to factor. So in the numerator, I see that we have 4 a's in common. Okay, so I'm going to have a to the 4th power, and what's left is a b minus 2. And on the bottom, we have 3 a's in common. So if we factor out of a cubed, we get 2 minus b. Alright, when we get to this step, technically b minus 2 and 2 minus b are not the same thing. So what I'm going to do is I'm actually going to take the top factor, and I'm going to switch these two around. So when we switch them, this negative still stays with the 2, so we have -2 plus b. That's not the same thing as 2 minus b, because the signs are off. However, if we factor out a -1, we can say -1 times 2 minus b. So now that actually looks the exact same as my factor on the bottom. Okay, so let's rewrite the numerator with this factor. So we have a to the 4th times -1 times 2 minus b over a cubed times 2 minus b. Now we're going to look for common factors that we need to cancel. And in this case, we can get rid of 2 minus b. And this is saying that we have a times a times a times a divided by a times a times a. We actually have 3 of these a's that are going to cancel out on the numerator and denominator, and we're going to be left with an a. Okay, so we're left with an a times -1. Everything else was canceled. So our answer is -a. Alright, so our key concept. If we're multiplying rational expressions and they're separated, that means when we multiply them, we can actually put them together. So the numerators can multiply with the numerators, denominators multiply with denominators. When we are dividing rational, it's just like you would with a fraction. So we say we have 5/4 divided by 1/2. Well, the way you would solve this, you would actually take your denominator, you would flip the fraction, and then you would multiply straight across. So we would actually take 5/4. If we flipped 1/2, that would give me 2/1, and then you would multiply straight across. So we'd take 5 times 2, which is 10, 4 times 1, which is 4, and then you reduce. Okay, so we're actually going to do the same thing we would with a fraction as we would with rational functions. So example 4, we're going to multiply and divide rational expressions. We're going to simplify. Okay, so we can actually take these things and multiply them. So we're going to put the numerator together, 8x times 7y squared divided by 21y cubed times 16x cubed. Alright, so this actually becomes a problem that we can simplify pretty easily. We want to take 8 times 7, which is 56. So we get 56xy squared divided by 21 times 16, which is 336 And then we have x cubed, y cubed. All right, the last step, we're actually going to take this fraction and reduce it. And it actually reduces to 1/6. All right, so we have 1x on top times 2 y's. And on the bottom we have 3 x's. 2, 3, times 3 y's. 1, 2, 3. All right, so this x cancels with this one. And then we have these 2 y's will cancel with these two. So our answer is going to be 1 over 6. We have 2 x's, so x squared. And we have 1 y left, so y. And that's your answer. Alright, so the next example, we're actually dividing these. Anytime you see this divide sign, you want to take this second fraction and you want to flip it. After you flip the fraction, then you need to change the divide sign to a multiply sign. So that means we actually have 10mk squared divided by 3c squared times d times 6c squared d squared divided by 5m to the 5th. So now we can actually do what we did in the last example and combine our numerators and combine our denominators. I'm going to take 10 times 6, which is 60, mk squared c squared d squared divided by 3 times 5 is 15. Let's see, I wrote m's first, so I'm going to write n's first on the bottom, so m to the 5th. I wrote a k next, but there's no k's on the bottom. C, so we have a c squared times d. Alright, so from here, we're going to take 60 divided by 15, which is 4. Let's see, this is like saying m times k times k times c times d divided by 5 m's, 1, 2, 3, 4, 5, times 2 c's times a d. And let's go ahead and cross out. So we have 1 m to cross out. We have no k's. We have 2 c's to cross out. And 1 d. So we're going to rewrite our answer as 4. We have 2 k's and 1 d on top divided by 4 m's. And that's our answer. Example 5, we're going to simplify this polynomial. Alright, so the first thing you want to do is actually factor. Alright, so here in this numerator, we actually have a difference of squares. I'm actually going to switch those around first to get negative k squared plus 1. And then I'm going to factor out a negative 1 to get k squared minus 1. Alright, so the next thing I'm going to do is, since I know that this is a difference of squares, I write k and k, plus and minus, and square root of 1 is 1, so 1 and 1. Okay, so I'm going to rewrite this as k minus 3 divided by k plus 1 times, we have negative 1 times k plus 1 times k minus 1 over, now we have to take k squared minus 4k plus 3, and we have to factor that as well. Alright, so 3 is our magic number. The factors of 3 are 1 and 3. We can actually manipulate those to get a 4. Okay, so we have k and k. Whatever the bigger factor is gets this middle sign, so minus 3. And in order to get a positive 3 when we're multiplying, we have to take 2 negatives and multiply them together. Okay, so we have k minus 3, and k minus 1. Alright, so now we're going to look for common factors to eliminate. Okay, so it looks like we have a k minus 3 on top and a k minus 3 on bottom. We have a k plus 1 on top and a k plus 1 on bottom. And looks like we have a k minus 1 and a k minus 1. So the only thing that's left is this negative 1. And that's our answer. So this is equal to negative 1. So we're going to do the same thing, except now we have division. So anytime we see a division sign, make sure you take this second fraction and flip it, and then change the division to a multiplication sign. The next step, after we have rewritten it, is to factor everything. So I'm going to start with my first numerator. They both have a 2 in common, so I'm going to factor out a 2. And what's left is a d plus 3. And I'm going to factor its denominator. So we have d and d. Factors of 2 are 2 and 1. And we want to have this minus sign goes with our bigger factors, so we have a minus 2. And we need to get a negative 1, so that this is actually going to have to be a positive 1. Okay, so the next one we have d squared plus 3d plus 2. Magic number is 2. Factors of 2 are 2 and 1. Okay, so we have d and d, 2 and 1. Bigger number gets the middle sign. We have to multiply to get a positive 2, so that means this one has to be positive as well. Divided by d plus 3. Once we get to this step, we need to eliminate common factors. So, looks like we have a d plus 3 and a d plus 3, one in the top and one in the bottom. And we also have a d plus 1 in the numerator and a d plus 1 in the denominator. So what's left is a 2 times d plus 2 divided by d minus 2. And that's your answer. Alright, so for our next example, we're going to simplify a complex fraction. Okay, so think of this as the same way as if it had these two next to each other and you had a division sign. Okay, so we're going to flip the second fraction and multiply. So when we rewrite it, it looks like x squared divided by 9x squared minus 4y squared times 2y minus 3x divided by x cubed. Alright, next step is to factor everything. So the only thing that can be factored is this 9x squared minus 4y squared, and this is a difference of squares. So we have x squared divided by the square root of 9x squared is 3x. So we have 3x and 3x. Square root of 4y squared is 2y. So 2y and 2y. And we have the opposite signs, so plus and minus, times 2y minus 3x divided by x cubed. Now we have to look for factors that we can eliminate. The problem is we can't just eliminate one of these factors because they're not the exact same. We have to flip this second fraction around and factor out a negative 1 in order to make it look like 3x minus 2y. Or else you can't cancel it. So I'm going to flip it around. Negative 3x plus 2y. If we factor out a negative 1, that's going to give us 3x minus 2y. Alright, so I'm actually going to rewrite this top as negative 1 times 3x minus 2y. Now I can find factors to eliminate. So we have the 3x minus 2y, 3x minus 2y. This is basically saying we have 2 x's, and this is saying we have 3. So we have 2 x's that cancel with 2 x's. So what we have left on top is a -1 over, and what's left on the bottom is 3x plus 2y. And that's your answer. Thanks for watching.